graphing radicals. Before we look at these problems, let's first go back here and take a look at y equals the square root of x. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, 0, 0. That's our, I'm going to put center in quotes because we can't go negative. Okay, so that's our center or our start. Then we have 1, 1, 4, 2, 9, 3. Here is our parent pattern. Remember back in Unit 2 when we talked about patterns, this is a parent pattern. Over here we have y is equal to the cube root of x. We have our center point. Then we have our pattern. Our pattern is right 1, up 1, right 8, up 2. The cubic root of 1 is 1. The cubic root of 8 is 2. This is symmetrical about a point, about the origin. So that means whatever I do on the right, I do the opposite on the left. I go negative 1, down 1, left 8, down 2. From here, remember that both of these follow y equals a, the nth root of x minus h plus k. A is our vertical stretch or vertical compress. Here, h is when we move that center or starting point left or right. And k is our up or our down. And then the nth, this right here, gives us our shape. You gotta make sure you're doing the correct one. So, if we look over here to the next page, this first one, the negative out front reflects it over the x-axis. The 3 tells us that we're going to go right 3, and the 2 on the outside is up 2. We also have to notice that this is a square root. So that means we start someplace and we go in one direction. So I'm going to take, and here's my starting point. Now, I said that I'm going to go right 3 and up 2. So I put my point there. Now, I know that my pattern is 1, 1, 4, 2. Well, because it's reflected, I'm going to go down instead of up. So right 1, down 1, right 4, down 2. And then I'm going to connect with my smooth curve. My domain, this is, remember, left to right. So I start at 3, and I've got a bracket because it's actually at 3, and it keeps going to positive infinity. The range is always bottom to top. The bottom is at negative infinity. Infinities always get parentheses. And then it comes up and it stops at 2. And it gets a bracket because it's a hard stop at 2. Number 2, this is a cubic, so I know I'm going to have the S shape. It's got a vertical stretch of 2, left 4, down 1. So I'm going to take my point. I'm going to go left 4, down 1. Now I'm going to use my 1, 1, 8, 2 pattern. Right 1, up 1. But wait, I've got a vertical stretch of 2. So I have to multiply my up down by 2. So that means I'm going to go right 1, up 2. Right 8, up 4. What I do on the right, I'm going to do opposite on the left. So I'm going to go left 1, down 2, left 8, down 4. Okay, so 1, 2, 3, 4. Oops. 2, 4. My bad there. Look at that. Here we go. So then this should be the graph. Okay? Now, if you can't go all the way 8 one direction or the other, that's okay. Do what you can. Fill up the graph. Number 3 is also a cubic. This one is reflected over the x-axis. Right 1, up 2. Here's my starting point. I'm going to go right 1, up 2. It's reflected, so instead of going up, I'm going to go down to the right. So I go right 1, down 1, right 8, down 2. What I do on the right, I do opposite on the left. And then I connect with my smooth curve. Now the domain and the range for cubics, always negative infinity to positive infinity. It goes up forever, down forever, left forever, right forever. Finally, the fourth one, this is another radical. So if we take a look at this, I put my starting point here. It's reflected over the x, reflected over the y, and down 4. First things first, I just move my starting point down 4. Now, instead of going right and up, I'm going to go left and down. So I'm going to go left 1, down 1, left 4, down 2. And I draw my curve. Okay? That's it. Now, the domain and range, again, left to right, bottom to top. The left, negative infinity, up to 0. Boom. The range, again, negative infinity, up to negative 4. That's all there is to it. Graphing radicals.